So I'm talking here today on quantifying some topics that have been hugely important in the last 6 months down south, and that's this the fire for climate change debate that's been sparked by the bushfires down south. We've been doing some similar research in this space at CDU for some time. The talk I'm going to just briefly touch on today is looking at themes along this sort of line: climate change impacts on northern ecosystems. So we're going to look at that from the perspective of carbon and water cycles. And also we've been working a little bit on land use change, how that's impacting North Australian land systems, mainly looking at emissions from clearing. And our work in this space, where we're trying to look at carbon cycling, carbon coming in and out of our savanna landscapes, how that may inform mitigation and adaptation strategies, which you're going to hear a bit about that in the following speakers, Jeremy Russell-Smith and et al. So we might just focus on a couple of ecosystems. We've been doing a lot of work on tropical savannas, the dominant ecosystem across North Australia, and then a fairly carbon-rich coastal ecosystem, mangrove communities. We've been doing work there, again, on how much carbon's in these systems, where's it going when we disturb it. So cracking on, we've been funded by TURN and ARC over many years to set up monitoring sites across the NT. In the green of the territory sites. This is part of the AusFlux network, the Australian Flux network. At each site we can estimate directly by measurements of carbon dioxide exchange what sort of carbon sink we may be getting along a flux gradient. And you can see there's a whole bunch of red dots in the top end of North Australia that spans about 1,000 millimetre rainfall gradient. And so we're using this natural laboratory, this natural environmental gradient, to build a whole database on how our ecosystems respond to climate drivers. So effectively we're measuring photosynthesis, respiration and emissions from fire at these sites to build a carbon balance at a catchment scale or a plot scale, or once we scale up, we join up with the remote sensors and the ecosystem models, we can start looking at carbon sink dynamics across the savannas at a regional scale. So I've madly put some data here. My communications team are a little nervous about some of my slides, so I'm going to keep moving. But the big green number on the top left, 2,230, that's the mass of carbon coming into the ecosystem in grams per metre squared per year. And that's derived from these observations. We've got this data comes from the Howard River catchment. That's been under observation for nearly 20 years now. It's one of the longest term flux sites in the world. And that gives us 20 years of a period where we can actually look at climate change impacts. Are we seeing any shift in the amount of carbon that's coming in or out of this ecosystem? The answer is yes, we can. We've now got enough number to suggest that we've seen rainfall creep up across North Australia, and of course CO2 is building in the atmosphere, is driving, it's spinning that photosynthetic cycle, which is what that number represents, a little bit quicker. The number to the right is the respiratory cost of capturing that carbon. That's respiration, that's ecosystem scale respiration. We're all respiring right now. That's a process very dominated by temperature. So are we seeing a trend in increasing temperature? What's it doing to that respiratory loss? And the little green blob at the end is the bit that's left over. You can think of this like a bank account. There's so much comes in from the atmosphere, so much you spend to keep your trees and your grasses alive, and then you're left over a little bit at the end of the year. And of course that little bit at the end of the year is also then fuel for burning. So we need to sort of account for where all these carbon fluxes are going, and a large amount of that carbon we might sink or sequester then goes back into the atmosphere by our little fire emission. And then more recently we've been looking at how much of that carbon ends up in the groundwater, the soil, from the soil into the groundwater and into rivers and estuaries, that then ultimately finds its way back to the ocean or back to the atmosphere. So we're trying to close this carbon balance across the savanna environments so we can get to a point where we can say, well, these tropical savannas are a net sink or not. And in this graphic at the top of the screen, you can see a map of the tropical savannas where we've linked with CSIRO's modelling team who model ecosystem dynamics, used all those data points you saw on the graph previously to come up with a net sink or source estimation. And that's a weak sink. The savanna are a very weak carbon sink. However, once we then lay our fire emissions data that the RIEL fire team have developed, turns out that savannas are a net weak source of carbon. So we are actually emitting more carbon to the atmosphere than we sequester, despite us, certainly in the top end, living in a kind of wet tropical environment. Another environment that we've been looking at or interested in this sort of carbon cycling and climate change is coastal blue carbon, this sort of blue carbon ecosystems. These are wetlands, mangroves. They store enormous amounts of carbon. But how susceptible are they to climate change? We warm them or we disturb them from land use change. And that's been a big theme for us in North Australia. There's a bit of literature recently published assessing that potential for mitigation, and our data from North Australia went into this assessment. This is a Nature Communications paper. And lots of carbon sitting in these blue carbon ecosystems can also mean a very large emission when they're disturbed. And we also are asking similar questions of carbon in Indonesia in coastal ecosystems. They have a huge amount of carbon. How vulnerable is it to impacts from climate change and, of course, land use change? We're working in that space with Indonesia is a hugely important strategic link for RIEL, and this is, I guess, a component of many livelihoods activities with Indonesian colleagues that you're going to hear about later in the next session from Natasha Stacey. So here's some vulnerability for you. If you want some carbon vulnerability, this is the Gulf dieback that occurred in 2015-16. I think many people are aware of. It's been making some media. We went back there in 2019, and that's some photographs of one of the sites we've been interested in, where we've seen extensive dieback. So those who don't know, in the 15-16 wet season, we saw a huge dieback event right across the mangrove estate, across the Gulf of Carpentaria. We lost upwards of 9,000 hectares of mangrove. They're in various states of dieback. That's been subjected to a cyclone. So we're 4 years after the event. There's very little evidence of any regeneration. What regeneration may have been underway has now been lost by the impact of a fairly modest cyclone, it's a Category 1 cyclone. That site was impacted in December 18, and it's in pretty bad shape. We've lost some sediment from that system. We're after quantifying the loss of sediment. Where's that sediment gone? And we haven't even started quantifying the carbon loss that's going to arise from not only that stripping of sediment off the coastline, but the decomposition of those millions of trees that have been killed. So it's about 10,000 hectares, happens synchronously right across the Gulf, and it has to be a climate change impact. From our analysis, we're working with the NT Gov very closely. I've sponsored this work as we have teamed up with the Bureau. We're just having some technical issues here. Here we go. This is a slide taken about a kilometre from these other devastated points. This is what that system used to look like prior to the dieback event, and that little patch there is actually still living. So we have this very complex mosaic of complete destruction right through to some numerous blocks, or most blocks actually, that have survived. So we've got to work out why some areas have fallen over and why some areas have not. And the BOM is helping us work out what climatic drivers have we seen that's driven this event. And rainfall deficits is one, sea level drop driven by ENSOs is another, and of course people are asking what are the long-term impacts of this climate change event, how will that impact livelihoods? And the same set of questions we're asking in Indonesia. It's not climate change but land use change, it's agriculture where we're seeing widespread loss of mangrove from agriculture. How can we put that carbon back? How do we run restoration events? And I think I might leave it there. Thanks very much.